The crisis of human knowledge formation in AI society, algorithmic probability and human abductive hypothesis. Tomoko Tamari, Goldsmiths University of London. The emergence of ChatGPT and artificial intelligence with a large language model LLM has evoked a major debate on the potential risks to human creativity and imagination. DALL-E 3 AI-powered image generator has been speedily developed and made available to ChatGPT users. DALL-E E3 is built on ChatGPT and helps users to create effective prompts. OpenAI remarks on the formal website, modern text-to-image systems have a tendency to ignore words or descriptions, forcing users to learn prompt engineering. DALL-E E3 represents a leap forward in our ability to generate images and exactly adhere to the text you provide. Each user has to produce a prompt, which is a text-based command for operating ChatGPT. Hence, it is vital to provide ChatGPT with sufficient context, guidance, and information to create an effective and accurate performance. This makes us aware that language is an important medium to create a bridge between human knowledge and machine information. Consequently, this paper investigates both machine and human language systems in order to explore potential risks that can be produced in human-machine symbiotic knowledge formation. One of the characteristics of today's big data is a logical shift from causal relation to correlation. A correlation shows a relation which is based on statistical data. Now, supercomputers make it possible to perform intricate and complex calculations to deliver insight from the correlation between various types of formatted massive data sets. Not only inductive reasoning, but also abductive reasoning is involved in this process. What is inductive reasoning and abductive reasoning? First of all, reasoning is a process of logical thinking we use to make a decision, solve a problem, and make sense of the world. Inductive reasoning involves making generalization based on individual cases. While it is less reliable than deductive reasoning, it is more creative as it can help to generate new hypotheses without exceptional cases. For example, Beethoven died, Mozart died, Bach died, therefore humans die. By the way, deductive reasoning is a type of reasoning in which the conclusion logically follows from the premises. If the premises is true, the conclusion must be true. For example, human die, Beethoven is a human, therefore Beethoven must die. Abductive reasoning is often called inference to the best explanation to generate or evaluate hypotheses to explain a phenomenon. This is more creative than deductive reasoning, but requires the generation of potential explanation and available evidence to help evaluate whether the explanation can be plausible or consistent. For example, humans die, Beethoven died, hence Beethoven is human. But Beethoven is not necessarily a human, but could be a dog named Beethoven. We can encounter AI and big data analysis using abductive reasoning in many fields of everyday life. One of the most common is medical services. AI has now started to provide diagnosis and prognosis of your health condition and suggest what you need to do. Instead of going to see a doctor, you just need to use a phone to chat with an AI. This kind of AI medical health service allows users to describe their symptom in a casual way, while expert systems mine huge medical database using machine learning to string together correlation between symptom and condition. In this case, the AI identifies the diagnosis and decide on appropriate therapy, even in the face of diagnostic uncertainty. This is the abductive reasoning process, which AI with big data analysis conduct to generate the most plausible or probable explanation from the available evidence. Of course, human physicians practice abduction too. when they try to figure out what disease might explain a patient's symptoms. But her decision is based not only on medical big data, but also her own knowledge and experience. Despite its inherent uncertainty and potential mistakes, abductive reasoning is also an essential part of human language acquisition. Christiansen and Charter state that there is a fundamental misconception that words have clear meanings and are put together following well-defined grammatical rules. For them, language is formed in the manner of improvisation and in the state of searching for effective ways of communication. In this process, we can find abductive reasoning, which can be understood as a broader sense of inductive reasoning, but it is more open and creative to generate hypotheses to understand the situation and meaning of language, which describe such situation even involving potential risks and mistakes. Humans are known to be biased thinkers who prefer heuristic and quick decision-making, even in the face of making logical errors. This is called affirming the consequent fallacy or the contingency symmetry bias, which humans possess. For example, if you eat vegetables, then you will lose weight. You will lose weight, therefore you must be eating your vegetable. This is an example of affirming a consequent. It ignores the possibility that a person might be doing additional exercise or cutting calories in a different way. Humans often speculate to understand the phenomenon in a way which reverses the antecedent and the consequence. If A then B, then B therefore A. This way of thinking involves overgeneralization and reverse logical thinking. Hence, humans assume that a learned contingency holds true even when the other is reversed. Imai and her research group saying language is learned and founded on symmetrical relationship between symbols and referents. In this process, the contingency symmetry biases plays a key role in word learning. This bias is deeply relevant to abductive reference. So far, we have discussed that abductive reasoning is a vital process for both algorithmic probability and the human abductive hypothesis, but there is a definite difference between them. Human language acquisition have to be embodied, since we have a body. To consider this issue, it would be useful to introduce onomatopoeia or idiophone. Onomatopoeia refers to the naming of thing or action by a vocal limitation of the sound associated with it, such as birds or haze. We say birds like a bee. Onomatopoeia is considered as an icon to express bodily senses. The meaning of icon here can be understood as a sign which indicate a resemblance between the signified and the things being represented. In this sense, we can see that onomatopoeia's iconicity can make it possible to connect between what it appears, like a cat, and what is represented, meow, onomatopoeia, as meow sounds similar to a cat's voice. When babies acquire language, they very often use onomatopoeia, as it has many similar characteristics to language, which involves abstraction, but it is closely related to bodily senses and arbitrary but iconic. Onomatopoeia take a significant role in the way babies develop their language capacity to understand not only the embodied world, but also disembodied and abstractive language system. Lexman also points out that iconic onomatopoeic words are an integral part of language, and that the articulately copies are mimetic gestures produced by our vocal cord, facial muscle, and tongue. A good example is that the widespread phenomenon of the use of I, like sounds in words denoting small object or quality, such as tweety, weeny, tweeny, weeny, pimple, with the narrowing of vocal cords being iconic. So hence humans learn the words through embodied language. The cognitive scientist Stephen Hebnard criticized the logic of artificial intelligence grounded on the belief that human knowledge can be translated into symbols. He wrote, suppose you had to learn Chinese as a second language, and the only source of information you had was a Chinese dictionary. The trip through the dictionary would amount to merry-go-round, passing endlessly from one meaningless symbol or symbol string to another, never coming to halt on what anything meant. For him, what is vital to understand the meaning of language is that our efforts are grounded in the first language and in real-world experience and knowledge. We can only understand the meaning through embodied senses and experience in the real world. This is a symbol grounding problem. Meanings of language are determined and oriented by the way that our body works. Unlike ChatGPT, which needs large language model with an algorithm that has been trained on massive amount of text-based data, human babies start to learn words one by one to expand their language capacity through bodily and sensory experience. This is a vital process for humans to make the link between an object name and its meaning in the complex language system of the real world. In this process, abductive inferences, which generate and verify explanatory hypotheses, help inductively generalize language concept. Although LLM's algorithm can also be seen as using abductive reasoning, it is based on a probabilistic statistical data model, which is very different from abduction in human intelligence. Human abduction inferences cannot be based on mathematical rational calculation rather they rely on flexible, inspirational, and irrational or novel conceptualization and overgeneralization through embodied experience. This is a key process in expansion of human language system and knowledge formation. ChatGPT generates huge volume of text-based knowledge without involving the intrinsic traits of human language ontogenetic processes. Machine-generated knowledge recursively integrates and becomes part of the metadata of LLMs. This can distort human abduction inferences and conceptual creativity so that it produces serious risks in knowledge formation mechanisms. Thank you for listening.